Okay, so a blank is a mapping or a pairing. First of all, I don't like definitions. We're not going to do very many definitions. This is probably the most formal we'll ever get. Normally it's just a general idea, and that's what we're trying to get here. A blank is a mapping or a pairing of input values with output values. In regular talk, here's what that means. You got two things, and they're going together. Okay, for example, if you had like a boy and a girl, and they were hanging out sometimes, and every once in a while they'd send a snap back and forth, and, you know, maybe they went to the movies on Friday night, what would you say those two people are? They're in a what? They're in a relationship. Same thing in math class, only there's no boats involved. So it's just a relation. It's a math joke. No ships, no boats. She's not here. No. It's a relation. Yep. It's a relation. So a relation is just X and Y put together. Input and output value. You got two things together, they're in a relation. The set of input values, so the numbers that you plug in, we call those the domain or the X values, depending on the problem. We normally plug in our X values. That's our domain. So the set of output values, if input were X values and domain, what do you think inputs or output's going to be? Range, domain and range, or in other words, the Y values. All right, and again, this whole chapter's got a special name. This chapter is called a function, and that's what we're doing on the front side of this paper. A function has exactly one Y value for each X. Okay, so in other words, every single X value only goes to one Y value. So the number 2 X value can only go to one Y value. And if that doesn't make sense, we're spending the rest of the front of our notes explaining what that means. Okay? So let's look at that a little bit here. Let's look at it a few different ways. So for each of these problems, we're going to look at it 3 ways. We're going to look at it with a mapping, which is this thing right here. We're going to write some ordered pairs, and then we're going to graph it to see what that means. So input and output. So what does input really mean? X's. Output means X's and Y's. We're just drawing some arrows. So this is a weird way of doing things, but it's called a mapping. You're just drawing arrows to connect X's and Y's. So instead of doing it that way, I'd always rather write it as ordered pairs. So what 3 ordered pairs, Chanel, what ordered pairs are represented by that mapping? Negative 3, 1, because she's going from there to there. 2, 3. 3 and negative 2. That's all it is. It's just 3 ordered pairs. Okay? There's a mapping of them. I wrote them as ordered pairs. If I put them on a graph, it would look like this. Negative 3, 1. 2, 3. And 3, negative 2. Cool. It's 3 dots. All right? If I wanted to make it, just so we have a better visual of it, I'm going to connect the dots. You don't really have to do that, but I'm just showing you a visual. Something like that if we graph dots. Cool. This one right now, I'm just going to tell you that this is a function. That right there is a function. Number 1 is a function, or letter A. Letter B. On letter B, you got 4 ordered pairs. Deasia, what ordered pairs do you think you have here? 1, 0. 2, negative 2. Yep. And 3, 4. Good. She went through and just looked at all the arrows and connected them. If I were to graph them, it would look something like this. 1, 0. 2, negative 2. 2, 1. And 3, 4. I don't know why I connected the lines the first time, but if you did, it's fine. This one right here, letter B, this thing is not a function. Okay, I'm not going to really explain it yet. I want you to try to make some ideas here. This one right here is not a function. Everybody see those two things? Try letter C, write the 3 ordered pairs and graph it, and then try to make a decision whether it's a function or not, and we'll explain what the actual answer is here in a second. So try that real quick. On this one, I'm writing my 3 ordered pairs. I get 1, negative 2, 2, negative 2, and 3, negative 2. if I were to graph them, it'd be 1, -2, 2, -2, and 3, -2. Looking at these two examples up above, okay, we said that these two up here were, this was a function, number 2 was not. Number 3, thumbs up if you think letter C is a function, thumbs down if you think it's not. Thumbs up if you think it is, thumbs down if you think it's not. It is a function. Anybody remember why or can make a reason? Vertical line test would be important. Let's look at the vertical line test. Let's look at our first two examples here. Okay, here's what the vertical line test says. If you take this line and you cross it across your graph, you can only touch each point one time. You can only touch one point at a time. So tell me stop when I touch my graph in more than one spot. Did I touch it ever more than once? No, so it passed the vertical line test. Let's look at graph number 2. Okay, tell me stop when I touch it more than one spot. Stop right there. I'm touching 2 points vertically on top of each other. That means it doesn't work. Okay, that is not a function. Let's continue that idea down here. So as I move this line across, tell me stop when I touch it more than one spot. 1, 1, 1. That one passes. That's why it's a function. Any other ways we can make that decision besides vertical line test? Awesome. If the x is double, if your x's go to 2 different y's, so this one, -3, 2, and 3. That one's cool because the x is never repeated. But on this one, my x value went 1, 2 goes to -2, and 2 goes to 1. If your x repeats to 2 different values, that makes it not a function. So this last graph, 1, 2, and 3, we're good. Our x's didn't repeat. Our y's can repeat, but we're worried about x's. So let's look at these graphs. We've got 4 graphs. All we're going to do is give a thumbs up, thumbs down. Yes, it's a function. No, it's not. On number 1, give me thumbs up if you think it's yes, a function. Thumbs down if you think it's not a function. On number 1, everybody should be giving me a thumb here. Taylor, number 1, thumbs up, thumbs down, yes or no on a function. Let's check. Tell me stop when I touch this graph in more than one spot. Ever touch it in more than one spot? And it passed, so yes, it's a function. Let's look at the next one. Thumbs up, thumbs down on number 2. Thumbs up, thumbs down on number 2. Tell me stop when I touch the graph in more than one spot. Stop right there. I'm touching it right here and right there. It is failing the vertical line test, so it is not a function. Let's look at the next one. Tell me stop when I touch my graph in more than one spot. Stop, 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 stop. All of places. Okay, it always is touching more than one dot. It is not a function. Looking at the last one. Thumbs up, thumbs down on the last one. Yes, it's a function. No, it's not. Let's look. Never touch my graph in more than one spot. So yes, it is a function. Questions with graphs. Graphs are the easiest. Let's look at ordered pairs. So again, we're going to what Austin said there a little bit. When we're looking at ordered pairs, you could graph the points if you really wanted to, but instead, we're going to look for our x values. Did our x values repeat to different y values? All right, so looking at letter A, I've got my ordered pairs up there. Thumbs up if you think letter A is a function. Thumbs down if you think it's not. Everybody that's not taking your test should be giving me a thumb. Should know. Thumbs up or thumbs down on letter A. Let's check. I've got 3, 5, 7, and -7. Did my x's ever repeat? Nope. So that one is yes, a function. That's what we're looking for. X is repeating or not. Letter B. Thumbs up for yes, thumbs down for no on letter B. I see 2 right answers only. Letter B is yes. Okay, this one's a tricky one, but letter B is yes, it's a function. Austin, why do you think that one's a function? We're looking at our x's, so 3, 5, 2, 3. Oh no, my x is repeated. That's a bad thing. My x's can't repeat. But we said our x's can't repeat to different y's. So this is just kind of a weird thing, but that one's 6 and that one's 6. There's still a monogamous relationship. That x is still going to just one y value. It's the same one. So if I see the same point written twice, I'm just like, I don't need that other one. It's just redundant. Okay, I don't need that. It's still a function. We're good. Does that make sense on that one? It's a little bit weird, but it's not crazy. Letter C, say yes or no when I count to 3. 1, 2, 3. No, let's look why. 2, 5, 2. Uh-oh. X is repeated. Different y's? Yeah, that's bad. Okay, so that one's not a function. Krista, what do you think on D? Yes or no? No, why not? The 3's repeat to 2 different y's, so that one's not a function. Letter E, Sarah, yes or no? Yes, but my X is repeated. I got 2 negative 2's. The output, the y is the same, so we just start like, oh, I don't need that one. Negative 2, 4, 0, those x's are all the same, so are not the same, so we're good there. Questions with ordered pairs? Just be careful with the redundant ones. Last thing here is I want you to fill out this table. So you're picking numbers to plug in here. Make this first one with the numbers given a function, and make the second one not a function. See if you can do that. Felicity, what'd you say for this first one? What'd you put in these columns? 20 and then 7. 3 and negative 6. Okay, cool. Why do you think that one is a function? None of the x's repeated. She's got 20, 15, 7, and 1. She's good there. None of them repeated. Brian, what'd you put on the second one? 1 and 3. Why are you saying that one's not a function? Two x's and they both go to different y's. A 2 and a 1, that makes it not a function. Does that make sense there? Cool. Flip it over.